if they want to join. Okay. Alright, so before we start our class, okay, so I think you already noticed that I already left an assignment for you in Google Classroom. So I want all of you to do, okay, and send it back to me, okay, submit to me. Okay, so that one is actually exercise for the graph, right? So it's the same, okay, as we did before, okay, and you have to use a ruler to measure the length of S, okay, so use your ruler. Okay, so we move on to the second questions. Okay, so question number 2, right? So diagram 2 shows the result of an experiment to investigate the relationship between force and acceleration. Okay, so this one is actually the Newton's second law, F is equals to ma, right? And then for an object which move on a rough surface. Okay, all right, so this is the graph. Okay, so this is the graph. Right, so F against A, acceleration, okay. All right, and then based on the graph in diagram 2, determine the value of F when A is 0.0 ms negative 2. So you can see the question said show on the graph, right? Show on the graph, okay, how you determine the value of F. So mean you have to show on the graph, okay. So how? All right, so this one you have to make this line longer. So take your ruler. Okay, take your ruler. Okay, and make the line longer, straight line. Okay. Hmm. Want to change the color first, wait. Okay, let's change it to red. Okay, and the width is okay. Right? So after that you read, okay, you read the point that the line is intercept at y-axis. So what is the value there? Okay, so you can see this is a 20 box, small box, so means 10 divided by 20, right? So 10 divided by 20 is what? Use your calculator. Wait, I open the wait. Wait for a while. Okay. Wait. Audio off. Right, so what is the answer? 0.6, is it? because 10, this is 10, right? So means 10 divided by, sorry, this is 20 small box, right? So 10, 10, 20. So you want to know one small box is equals to what? So 10 divided by 20, right? So 0.5. Okay, so 0.5 for each small box here. So this one is actually 5, right? So 5, okay, 5, 5.5, 6. Okay, so you got 6 Newton. Okay, so the answer for this one is 6 Newton. Okay, so 1 mark for the line and 1 mark for the answer. Okay, so are you clear? Any questions you want to ask? All right. So the next question, all right, what will happen to A when F is increased? So what happened to A? Okay, so when A is increased, so you can see the value of F also increase. Okay, so the answer is increase. Okay, increase. Okay, all right, and then next question, based on the graph in diagram 2.1, okay, calculate the gradient of of F against A. So if you want to calculate a gradient, I already told you, you must have a triangle. Okay, so the triangle, the size of the triangle must be 4 times 5 or 5 times 4. Okay, so what is 4 times 5 and what is 5 times 4? Okay, so this one is actually is equals to 1. Okay, so let's say if I take let's say I take this coordinate. Okay, example, right? So I say I take this coordinate. Okay, and then I take another one is here. Okay, let's say another one I take here. Okay, so then I draw a triangle. Okay, so I draw the triangle. Okay, from here goes to till here. Okay, so until here. Okay, so this is the first line. Wait. Hmm. Okay, right, and then another one, this one. Okay, this is only example. Okay, all right, until here. Hmm. Okay, so right. Okay, so let's say this is my triangle. So I said 4 times 5 or 5 times 4. So you calculate the box here. So this one is actually equals to 1. So this one is actually half only, right? So 1, 2, 3, half. Okay, so 3.5 here. Right, so this one is 1, 2, 3, 4, 5, 6, right? So 6. So it's still not enough because I said already the minimum, right? The minimum is 4 times 5 or 5 times 4. So what you can do is you try to calculate. They say if I want to take from this point, so 1 here, right? 1, 2, 3, 4. Okay, so they say, teacher, if I want to take more than 4, yes, take until here. It's easy for you to read the coordinate later, right? So you just take from here to here. So 1, 2, 3, 4, and then it's 4.5. It's okay, right? So as long as more than 4 or equal to 4. So they say I take until here. Okay. Alright, and then this one is enough because it's 1. So this one, if not enough, you have to make it longer. Okay, so you have to make this line longer. Okay, so make this line longer. Like that. Okay, so your line is until here, right? So make it longer from here to here. Okay, and then this one you move it to here. Okay, then make it longer until that. Okay, until here. Okay. So now this is your triangle. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So it's more than 4 times 5 or 5 times 4. Okay, so it doesn't matter whether you want to put here 5 box or this one is 4 or this one is 4 box and this side is 5 box. Okay, it doesn't matter. So your triangle, the minimum one should be 4 on this side or 5 on this side or 4 on this side or 5 on this side. So are you clear? Anything you want to ask teacher? I don't think so. So means you understand. Okay. Okay. So next step, okay, you have to read the coordinate. Okay, so let's say this one, I take this coordinate. Okay, so this should be 0, this should be 1, right? So 1, 10. Okay, so after you draw a triangle, okay, after you draw a triangle, you take the coordinate and then you have to write the coordinate at the point there. Okay, all right, and here, okay, here is the x-axis is 10. Okay, so 10. Okay, and then the y-axis is, this is 45, right? So 40, I think here is 49. Okay, so 10, 49. Okay, and then after that, use the gradient formula, right? y2 minus y1 divided by x2 minus x1. Okay, so I have to calculate here. So y2 minus y1, x2 minus x1. Okay, so y2 here is, they say I take this one, xy, s1, y1, x2, y2. Okay, so means 49 minus 10 divided by 10 minus 1. Okay, so 49 minus 10, okay, divide by 10 minus 1. Okay, so can you please try to calculate for me? 39 over 9 is 4.33. Thank you. Thank you. Thank you. So 4.33. Okay, so don't leave your answer in fraction. Okay, then the gradient, I told you before, gradient must have a unit. So what is the unit for the gradient? The y-axis unit divide by x-axis unit. So the y-axis unit is n, the x-axis unit is ms power of negative 2. Okay, so n divided by ms negative 2. Okay, so this is the unit for gradient. Okay, so far are you clear how to draw the how to find the gradient, how to draw the triangle in the graph? Okay, any question you want to ask teacher? No. So let's say if you don't understand, please tell me. Okay, let me know, with you again. Okay, so this is 3 marks. So where's the 3 marks come from? The first one come from the triangle that you draw. So if it's big enough, okay, then you get 1 mark. Okay, and then the second one, okay, when you substitute in the formula, 1 mark. Okay, and then another mark with the value here, the correct value with the gradient. Okay, so another 1 mark. Okay, so let's say because each of you sometimes you will take different point from your friends, right? So maybe some of you they take from here to here. So means you will get a different value of the gradient, right? It's okay because in the exam they will give a range. Okay, so means from what value until what value that can be accepted as a answer. Okay, So you don't have to worry about that. Okay. So just make sure the triangle is big enough. You read the coordinate correctly and make sure you calculate it correctly. Okay. All right. Number 2. Okay. The acceleration is determined by the equation F equals to ma plus c, where m is the gradient of the graph and c is the f intercept. Okay, by using the gradient m of the gradient in C1, determine the acceleration when f is 14.0. So they give you the equation f is equals to ma plus c. Okay, m is actually the gradient here that we already calculate, 4.33. Okay, so 4.33. Okay, so I just substitute in here. Okay, and then the f is 14. Okay, the f here is 14. Okay, and then ask you to find the acceleration, means a here. Okay, and then the the y-intercept we already know. Okay, here, right? This is the y-intercept. So the y-intercept is 6 Newton. Okay, so you just put here 6. Okay, then you find a. Okay, so this one just use the equation given, then you just substitute with the value that been given and also the gradient that you already calculate. Okay, so can you give me the answer for A? 8 divided by 4.33, right? 1.85. Okay, so good, thank you. 1.85 ms negative 2, because the acceleration the unit is ms negative 2. So this is the answer. Okay. Alright. Next question. Name the physical quantity represented by the gradient in C1. Okay, in C1, alright. So I told already this is actually the Newton's second law, right? F is equals to ma. So this is the graph of F against A, right? So F against A. So actually this one, M is a gradient of the graph. Okay, M is actually equals to the gradient of the graph. Okay, so what is M actually? M is a mass. Okay, so M is a mass of an object. Okay, mass of an object. Okay, for E, state one precaution step should be taken to improve this experiment. Okay, this sentence I want you to remember. Okay, so for all the experiments, so let's say the question asks you the precaution, this is the only answer that can be acceptable for all experiment. Okay, so just memorize the word and you need to fill in the blanks, right, with the measuring tool that you use. Okay, so I give you an example here. So this is the sentence that you need to remember. Make sure your eyes is perpendicular to the scale reading. Okay, so let's see what is the measuring tool that we use here. Okay, so from the graph you can see is you have a meter here, right? Meter, and then they have a Newton here. Okay, so meter, that means you have to use a meter ruler. Okay, so here make sure your eyes is perpendicular to the scale reading of meter ruler. So this one I'm underline it because this one you have to fill, okay, on your own. Okay, depend on what the experiment that you did. Okay, so make sure your eyes is perpendicular to the scale reading of meter ruler. So for this one we use a meter ruler to avoid parallax error. Please remember this precaution. Okay, This one can be acceptable for all experiment as long you put the correct measuring tool. Don't leave out any words. Even one word, don't leave out. Okay, just put all the words. Just memorize and copy back, then replace the measuring tool. Okay. Alright, so this is the precaution. Okay. So 1 mark. Okay, so this the example of paper 2 questions. Paper 3 number 2 questions. Okay. Anything you want to ask teacher before I move to the 2.1? No. Okay. Alright, so we finish for tutorial 1, okay, for chapter 1. Okay, now we go to chapter 2. Okay, so chapter 2, forces and motion. Okay, so actually when for KBSM, right, for this chapter they combine like 11 topic in it for KBSM from 2020, the last batch. Okay, but for your KSSM they divide it into 2 parts. Okay, so when you form 5 you will learn forces and motion 2. Okay, so form 4 forces and motion 1. Okay, so they divide the chapter because the chapter is actually very long for forces and motion. Okay, so analyzing linear motion. What is this actually linear motion? Anyone have idea what is a linear motion? What does it mean by linear motion? Sorry. Anyone has idea what does it mean by linear motion? It's okay if it's wrong. I just want your idea, your opinion. Why is this actually a linear motion? Moving toward a straight line, motion in a straight line, right? Very good. Okay, so means linear is actually a straight line, right? So what you will learn in this topic is the motion that move in the straight line. Okay, only move in a straight line, not in the curved way. No, only a straight line. Okay. Alright, so linear motion is a study of moving object in a straight line. So how will you describe the motion of the runner in words? So we describe linear motion in terms of distance, right? Displacement, speed, velocity, acceleration, deceleration. So all these words, right, we use to describe the linear motion. Okay, so you will see what is the difference between distance, displacement, speed, velocity, acceleration, and deceleration. Okay, so Siti is standing in front of Liz restaurant. Okay, right, so Siti has been told to go to textile shop located 20 meter from where she is standing. So where is the location of the shop? Is on the right. If I was sitting here, so it's on the right. But for this, okay, for this is on the left. Okay. Alright. So this is the sentence here. You can see is located 20 meters. So they only give you the magnitude. Okay, the magnitude. But they didn't give you the direction. Okay. So alright, next one. So Siti has to walk for a distance 20 meter. So she walks 20 meter to the right. So her displacement is 20 meter to the right from Li's restaurant. Okay, so let's say if I have two sentence here. Okay, so Ali walks 20 meter. Okay, and then another one, Ali walks 20 meter to the right. Okay, so what is the difference here? Okay, so this one they got only the magnitude, Okay, and this one they got the magnitude and also direction. Okay, so number one statement, this one we call it as a scalar. Okay, and this one we call it as a vector. You remember, right? We learned on chapter 1, right? Only magnitude we call it scalar, magnitude and direction we call it as a vector. Okay, so this physical quantity we call it is as a distance. And this one with the magnitude and also with the direction we call it as a displacement. Okay, so this is the difference between distance and displacement. Okay, distance only got the magnitude, and for displacement they got the magnitude and the direction. Okay, so you can see here her displacement is 20 meter to the right. So see, you got the magnitude here and also got the direction. So we call it as a displacement. Okay, but for this one only got distance, all right, without the direction, we call it as a distance only, all right, only got the magnitude here, no direction. So distance is a scalar and this one is a vector. Okay, so are you clear about distance and displacement? Distance, no direction. Displacement, direction with magnitude. Distance, only magnitude. Okay, and distance is a scalar magnitude and displacement is a vector magnitude since it has the magnitude and direction. So are you clear about the distance and displacement? Any question you want to ask? No. Alright, next one. Okay, in this simplest form of motion, motion is straight line or linear motion will be analyzed. Okay, so linear motion is a movement in the direction. Okay, so let's say we move forward. Okay, if move forward, with the value will become positive. Okay, if move backward, the value of magnitude will become negative. So let's say I give you an example. Okay, so let's say this is Abu. Okay, so Abu walks 50 meter. Okay, then turn back, okay, and walk 55 meter. Okay, so remember I said when we move forward is the value will become positive. So positive. Okay, so when we move backward it become negative. So negative 55. Okay, so this is the sign, alright. So because after this, when you want to calculate the total displacement and the total distance, you need to know where to put the positive and the negative signs. Okay. Okay, so let's try the activity 1. Okay, with a pencil, take a ride from position A to B and to the final destination C. Okay, so this is 2 meter and this one is 1 meter. Okay, so your total length is, alright, so you just add 2 plus 1, right? So 2 plus 1. If you want to go from A to C through B, so 2 plus 1. So the total length is 3 meter. Okay, so this one we known as the value is known as a distance. Okay, distance. Okay. And then now you repeat step 2, but now from A direct to the final destination of C. So means from A, go straight to C. Okay. So how you want to find this one? You use what? Theorem Pythagoras. Okay. So find for me the value of C. 2.24. Oh, so fast. Very good. Okay. So the value is 2.24 meter. So this value is known as a displacement. Okay, so you can see what does it mean by displacement. So displacement is actually, the meaning of the displacement is the shortest, okay, distance, okay, shortest distance in a certain direction. Okay, so this is the shortest distance, right? So displacement is actually the shortest distance in a certain direction, because you know displacement is a vector, so must have a direction. Okay, right. Are you clear about that? Any question you want to ask teacher? No. Okay, all right. Okay, so what is the distance? Distance is a total path length traveled by an object. Okay, and it's a scalar quantity. We already discussed about that. And then the SI unit must be in meter. Okay, alright. Then how about the displacement? The distance in a specific direction, or the shortest distance in a specific direction. Okay, so let's say this is the distance. Okay, this is called as the distance. So displacement is this one, right? So let's say if you took a marathon or something, okay, alright. So this one is the distance. So let's say if you want to the shortcut, right? So this is the displacement. Okay, shortest distance. Okay, so this is the same example. Okay, distance is okay. Alright. For diagram 1, right? Diagram below shows the difference between distance and displacement. Okay. So the length of the road, length of the line AB. Okay. So so let's say I put a value here. Okay. So from length of the road, so let's say this is a 150 meter. Okay, so length of the line AB, so let's say this is a 50 meter. Okay, so the length of the road is 150 meter. Okay, length of the line AB is 50 meter. Okay, so this is called as what? Length of the road is called as what? Distance or displacement? Okay, distance. Very good. This one we call it as a displacement. Okay, right, good. Okay, now I want you to try to answer for question number 2. Okay, question number 2, try to answer first. A1, A2, B1, B2. Okay, for this note, actually I already put in the Google Classroom. For those who want to print, you can print first. For those who want me to print, okay, you have to wait because I already sent to school. Okay, I try my best for you to get this week. Okay, and for those who still didn't get for chapter 1, okay, so after school you can come and take here, and it doesn't matter when you want to come because I already put after school here at the guard. Yeah, at the guard there you can take from there. So I got the chapter 1 and the tutorial 1. Okay, for chapter 2 I try my best to get it this week. Okay, for those who just maybe you change class before this, you are from another class, right? So for displacement, you have to put the direction too, right? Don't just put the magnitude. Tell me when you're already finished, okay? Anyone, some of you, like when I ask, only some of you that will respond in the message, right? The others like being quiet like that. So I'm not sure whether you understand or not. Okay. So maybe you feel shy or whatever, okay, so please make sure you really understand, okay. Then if you want to PM me later, you want to text teacher privately later, yes you can. Finish. All right, very good. Okay, so what is answer for A1? A1. 1.5 kilometer to east. Okay. Any other answer than 1.5? 1.5 kilometer forward. Hmm. Forward. Okay, for the direction, okay, it's better for you to use left or right, and then you use the north, south, west, east, okay. So don't use forward or backward, okay. 1.5 kilometer to the right. Okay, so 1.5 kilometer to the right. Okay, so every day Rahim walks from his house to the junction, which is 1.5 kilometer from his house. So I already told you forward, right? Forward is a positive, right? And backward is a negative. Okay, so forward is a positive value, backward is a negative. Okay, so positive 1.5. So we don't need to put the positive sign. So 1.5 kilometer to the right, or some of you put answer as is. Okay, correct. Right, and then 2, when he is at Warong Pak Din, 0.5 kilometer to the west, 0.5 kilometer to the left. Okay, right. So now from O he goes to A, right? So from O he goes to A, so already 1.5. And then when he want to go to Warong here, B here, this one is 0.5, right? 0.5. So the first O go to A is 1.5. And then when he turn back, okay, so it become negative, right? Because now it's a backward, so negative 1.5. Okay, all right, and then it move backward again, so negative 0.5. So you will get 0.5, okay, 0.5 kilometer to the left. Okay, are you clear? Okay, so I repeat again. First, it goes to O to A, 1.5, right? And then it turns back. Okay, so turns back is reverse, means backward, right? So backward means negative 1.5. So 1.5 to the Warong, okay, at 0.5 km. So now it become the negative 0.5. Okay, but we just ignore the negative, because the negative is actually to show that it moved into the right, right? So 0.5 kilometer to the left. We already interpret the negative is to the direction, as a direction to the left, right? Okay, so are you clear for 0.5? How do I get 0.5? Any questions? Right, good. Okay, for B. After breakfast, Rahim walks back to his house. When he reaches home, what is the total distance traveled by Rahim? Okay, so what's the answer? 4 km. 4 km. Right, very good. So Rahim walked back to his house after breakfast. Okay, after breakfast. Okay, so he go back to his house here, so 0.5. So now 1.5, okay, so now it's 1.5. The first one, you travel to the junction, right? So 1.5, and then add another 1.5. Okay, because distance, so distance you ignore the negative or positive value. You don't need to put the negative or positive, because this one is a distance, so just ignore. Okay, so 1.5 here from O to A, then go back to O is 1.5. So 1.5 plus 1.5, you will get 3. Okay, and then it goes back to B, go to the warung, so you get 0.5, and then he goes back to O. Okay, so you will get 4 kilometer. Okay, so means what's the point here that we can understand is, okay, when when it's involved the displacement, you have to be careful with the direction. Okay, you must take the negative or the positive value. Okay, it depends on the direction of the motion. Okay, if you move forward, you put positive sign. If you move backward, then you put a negative sign. But for distance, we ignore the direction. We just take the magnitude and then you just add all the value there. Okay, we don't put the positive or negative signs there. Okay, all right. And then number 2, what was the Rahim's total displacement from his house? So anyone, what is the total? Yes, good. 0 km. Okay, 0 km. Okay, 0 km. Okay, so anything that any object or any movement that go back to its original position. So let's say if I have like this. Okay, this is point A and this is point B. Okay, so first let's say the distance here is 100 meter. Okay, 100 meter. Okay, so first I say, okay, Kamal walk from A to B. Okay, so this one if is move forward, so positive 100 meter. Okay, and then it move backward. Okay, it move back to A. So become negative 100 meter. Because now the direction is changed, right? Backward. So negative. So what you will get, positive 100, negative 100, you get 0. Okay, so this is the displacement. So anything object or any object that move back to its original position, the displacement must be 0. Okay, but let's say this is the displacement. But for distance, what is the distance here? What is the distance here? For my example, what is the distance here? Displacement, yes, 200 meter. Distance is 200 meter. Because from A to B is 100, then I go back to A. So 100 plus 100 is 200 meter. So you can see the difference here. Okay. Yeah, very good, Junhing. Alright. Okay, any question you want to ask about the displacement and also the distance? No, okay, let's say for question number 3. Okay, try to do first. Okay, later when the school open, okay, let's say for on physics, during physics time, okay, you don't need to bring the textbook. Okay, I will tell you when you have to bring. Okay, because you can see all my notes in uh, PowerPoint, right? And also the exercise also I already give in the tutorial. Okay, so we don't need textbook. but I will need it when we do the experiment. So I will tell you like maybe 2 or 3 days, okay, before I need to use the textbook, then you can bring, okay. But for now, I'm not using it. Okay, and are you do you understand? Can you do it for number 3? Any questions? In the jungle drinking. Okay, can I call anyone? Because I can see only that same person answer my question, right? So let's try to call other people. Okay, give them chance to give answer also. All right, so let's see from the name here, who is lucky. See, when I say I want to ask, so more people left. All right, so try Jun Kiat, Chia Jun Kiat. If you cannot open your mic, you can just chat. So what is the answer for number 3A1? 3A1. 800 meter. Okay, so let's see is it correct or not. Okay, so in a jungle trekking activity, a scout is given compass and a map. He starts his journey from station A and is required to walk to station B, which is located 400 meter. Okay, and when he reached station B, he's ordered to go to station C that is 400 meter to the north. Okay, so 400 meter. So what is the distance traveled from station A? So 400 plus 400. Okay, very good. Okay, thank you for your response. Okay, then the next question. Okay, next question. Mm, Isaac. Isaac. Is it correct? Isaac. Is it correct? What is the answer for A2? Yes, alright. So what is the answer? I'll let you see the questions. Isaac, okay. So what is the answer for displacement? This one you have to use what? Theorem Pythagoras, right? So what is the value for AC? A, B, C. A is 400. 400. Okay. So how you want to find AC? Can you answer it or not? Still calculate. Isaac, are you okay? Can you answer it? You need your friend's help? We call another one. Head to the station C, which is located 400 meter at the northeast. Okay, so that is the northeast is the direction of, you mean the 400 meter is the displacement, is it? Okay, I wait. Wrong one. 565.69. Okay, so 565.69 is the displacement. Okay, so 5.65.69. Okay, and then the direction is northeast. Okay, correct. To the northeast. Okay, to the northeast. It's okay. Good. Very good. Okay, why does the answer in 1 and 2 different? Okay, so I call another person who is lucky to be called by me today. Mm, Liao Kaylee. Liao Kaylee. Yes, Kaylee. Kaylee, why is it different? Hi, teacher. Yes, hi. Right, so what's the answer, Kaylee? Why does the answer in 1 and 2 is different? Why is different? Why is it different? Because displacement is the shortest distance, I think. Okay. Good try. Okay. But the real answer is, okay, because the distance is what? Distance is a scalar, right? It's a scalar, okay, and it only has a magnitude, while the uh, displacement, you have a scalar and also it has a magnitude and also has a direction. Okay, so you have to put, okay, because distance is a scalar quantity, okay, while displacement is a vector quantity. So means this one you already state that actually the distance they got only the magnitude, right? For the displacement means they got the magnitude and also the direction. Okay. So vector quantity. Okay. Good try, because distance is how far something has traveled from A to B, while displacement is how far point B from A. Is how far something has traveled from A to B, while displacement is from B to A. B to A to B. Because you see here, it say it start from journey from A, and then last last destination that he has to go is at station C, right? So means it's actually if you put that distance is the total length and displacement is actually the shortest distance, okay, so that one still can be acceptable, because now it's not going from A to B only, it's travel until C. Okay, and you only mention until B only, so you have to put that until C. Okay, and you have to put that, if you put the meaning of the displacement, because displacement is the shortest distance, right? Shortest distance travel in a certain direction, that one can still be acceptable. Okay, distance is the total path travel, while displacement, yes. Okay, yeah, good, Kai. Okay, it's okay. Alright, we discuss. I like to hear your opinion. Okay, it's good, very good. Okay, alright. Okay, so I think I will stop until here first. Okay, so make sure you submit the homework I gave in the GC. If you have any questions, you can ask. Okay, especially because that one is you're not familiar with, right? The ticker time, okay, ticker tape. Okay, you don't know how to measure. Make sure you take from the first point until the last point. They given to you already, like S1 is until here, until where, from where. So you just measure that using a ruler. And for those who still you want to print but you still didn't print, okay, for paper 3 like that you cannot print two in one because all the reading will be different, right? Because two in one it becomes smaller, right? So your S will be different. And then one of you, I think Yang already did, and he still can get a good graph, but if you compare with the answer, it's wrong lah. Okay, so make sure for paper 3, for the reading like that, you cannot print two in one. For those who print, okay, if not, then it's okay. Okay, so any question you want to ask teacher before I stop my class? Teacher, I print again. Oh, really? Oh, okay, okay. Sorry, I forgot to mention earlier, right? Okay, okay. So thank you, class. Right. So see you on Friday, I think. Okay. So have a nice day. Okay. Goodbye.
Bye, teacher.
Bye. Bye.